I'm finna hop into the trio.
Hello.
Hey,
How y'all doing?
what?
Great, wonderful. Yeah, it's amazingly hot in here.
I was the first person in here. I've been waiting. I've been waiting to get in the Zoom
You
since
been
1:30.
waiting?
Yes, since
Awesome.
1:30.
Miss Ladybug, come up one and shut it up. Thank you. Cause you won't stop talking and I'm about to put you in the hallway. And that means today you got a zero. We're done with that. Shush up. Thank you. I'm glad you was the first, Isaiah, so I'm writing your name first. Roll call, Shanice,
Here.
Emma,
Here.
Isaiah,
Here.
Emma. Okay, cool. Great for me. Um, we are about to go into chapter 2, forces. Chapter 2, forces. You and I want to thank those that sent your homework in. Thank you for sending your homework in. You know your homework was the word pyramid or the word what? Force. Force. All right. So today's homework is vocabulary, of course, and that is choose 2 words of your choice, your liking, and make 2 more word pyramids, just like we did yesterday. Okay. Yes, sir. Where were you yesterday? Oh, and you didn't get on YouTube and you didn't get on live. So guess what your homework is tonight? Watch YouTube. Find yesterday's assignment on our channel, my channel, and watch it. So you'll know what to do. Okay. You're gonna need it because I took notes yesterday. I lectured yesterday. You're gonna need it. What is that? That is someone knocking on the door, trying to get in.
Miss Adams, why you can't do science with math?
Why I can't do science with math?
Yes, ma'am.
The reason I can't do science with math is because time, it's like time. And we be running out of time. That's why. I'm sorry.
Oh, hey, Miss Adams.
Hey, Holland, how are you?
Good.
I'm dead. I'm dead. I'm dead. I'm finna die.
Your battery's about to die.
Oh,
No,
no.
I'm
Oh my
playing the
god.
game.
Quit playing
Get
the
off
game.
the game.
Okay.
Okay, turn to page 61.
How do you keep rushing, bro?
Virtual, your stuff is in
Savas.
that's it.
All right.
I already did all of the assignments in Savas.
And you need to go back and check in and make sure you did it right. Okay? Because it is chapter 1 only. I mean lesson 1 in there only. I didn't give you another one. I did not give you another one, okay?
Uh-huh.
Because we are only doing chapter. Yes, ma'am. Who need a book? Who is Nicole? Where's your book, baby?
A new girl.
What you mean you don't have one? Everybody got one. Okay, let me say this. Everybody got a book.
I don't need
That's tough, bro. Man, get off that game, boy. What's wrong with you?
shit. Oh, bro, I just died, bro. I can't focus when you keep talking to me.
Get off the game.
Shut up, nigga.
Oh, you nigga.
All right, I'm about to share my screen, and y'all two stop fussing, please. I don't know who you're fussing with. Yes, ma'am. Thank you. All right, let's go. I'm gonna read, and then I'm gonna stop and I'm gonna ask questions, right? Those questions are test questions. I'm just letting you know, FYI. Forces. When one object pushes or pulls another object, the first object is exerting a force on the second one. A force is a push or pull that acts on an object. Let's highlight, underline, how you want to do it. Force is a push or pull that acts on an object. Highlighters back there in the popcorn bin. Anyway, moving on because time is ticking and I don't want to be late for getting you home. Every force has a strength or magnitude. Every force has a what? Okay, let's underline that. Every force has a strength or magnitude. And this strength is measured in units called newtons. And they're measured in what? Measured in units called
Newtons.
not figures, but newtons.
Oh.
A force also has a direction. What a force has?
A direction.
The direction of a force can be described by telling which way the force is acting. So a force has a direction. The dog is pushing the ball with a force of around 2 newtons. That's just an example. If you look at the dog pushing the ball, direction the dog is pushing the ball, and the arrow shows the dog is pushing and not what? Pulling. If he was pulling, the arrow be pointing what? Backwards, pointing behind him. Very good. Very, very good. All right, moving on. Forces can change the way objects move. When an object begins to move, it is because a force has acted on it. When an object is already moving, forces can make it up, slow down, or change directions. So let's highlight that. When an object is moving, forces can make it speed up, slow down,
slow down, or change direction.
So say for instance, we have a car. Car's in motion. A force makes it turn, change the direction.
Steering wheel.
Go on, you yelled out before I could get the answer. That's it, the steering wheel, very good. The steering wheel does that, very good. Say for instance, we have a ball and we roll the ball, but it stops.
It slowed down.
What you say?
It slowed down.
As much force as you put with that ball. Because I can take the ball, go, whoop, it might go and stop. I can take the ball, go, whoop, and it will just go on and on. So your force determines the speed and the direction of the ball. You got it? Very good, Tremont. Circle number 1. That's y'all assignment. Number 1.
Okay.
H. Contact forces. We talked about contact forces
Yesterday.
Awesome job of knowing what contact forces were. Contact forces. Car mechanics use forces to lift tires and pull tool carts. These forces cannot act unless the mechanic touches the object to be moved. The object may be touched directly with a hand or using a handle or a rope, but there must be contact. A force that requires two pieces of matter to touch is called a contact force. Highlight. A force that requires two pieces of matter to touch is called a contact force. So what two pieces of matter did I say that you got? What matter you must have contact force with?
What's it called? A magnet?
Oh, remember the example I gave earlier. The ball in your hand, right? The ball in your hand. So in order for the ball to move, you got to move, right? Yeah, you got to have contact with it. So you is matter, you are matter, and the ball is matter. So that's two different matters making touching.
Miss Adams, if you push the ball, is that energy?
That is energy. That's kinetic energy. Or is it potential?
It's kinetic.
It's like I got potential to move that. Yeah, it's standing still. So yes, it's kinetic energy. Very good, Shanice. Awesome. Hug your auntie for me. But that means y'all coming in here knowing something. All right. You exert a contact force when you push or pull a piece of furniture. Shush, honey bunny. One kind of contact force is
A magnet? Contact force?
with me. One kind of contact force is friction. Contact force, friction. I might ask you, name me a kind of contact force. Friction. And what is friction?
Friction is the force that results when two matter rub against each other.
All right, here we go. Let's read it coherently. Friction is the force that results when two materials rub against each other or when their contact prevents sliding. If I wanted to slide on this rug, I probably wouldn't be able to do it very well. Yeah, I get carpet burn because the carpet's gonna hold me some friction. If I rub my hands together real fast, that's gonna get hot, and that's still what? Friction. We did that yesterday. Friction makes it harder for one surface to move past another. The amount of friction between two objects may depend on their texture, shape, speed, and weight. Amount of friction between two objects may depend on texture, shape, speed, and weight. And it also may depend on whether or not the surfaces are wet. Also depend on whether or not the surfaces are wet. So if something's wet, is there friction?
No.
Because it makes it what?
It makes it
What makes it?
It makes it
Slippery. It's just gonna slide on by. Yes, slippery. Or liquid, yes. Solids are not the only materials that can cause friction. What you say? What else can cause friction? Air and water also resist motion when an object pushes against them. So air
And water.
also resist motion. Air resistance is a type of friction that is present when particles of air contact a surface. Particles of air contact a surface. Can somebody give me an example of air resistance?
Air.
Or tornado? Let's think about that. Because the definition.
It's in the sky.
Yeah, it is. An air resistance is a type of friction that presents when particles of air contact the surface. Air resistance. Resistance. What is resistance? Meaning what? I'm keeping you from moving. I don't think a tornado will keep something from moving.
Wind.
Okay, that's air, but you gotta give me an example of air.
Like when the wind, like when the wind is blowing on. Or the like when the air like or your air conditioner.
What about the trees swaying in the wind? Is that not air resistance?
No.
But the wind keeps going on, right?
Yes.
But so something's resisting that wind from knocking that tree over, right? So I would think the tree is getting some air resistance. Driving down, you ever taken your hand? Who is that? Yeah, it's air resistance. Great day, whoever is.
Me, that's me on the computer.
Miss Adams,
Yes.
it's no a friction.
It's no friction. No. How is snow friction? Yeah, you can move snow. Now that ice, you might want to think about it. When it become ice, you might want to think about it, but then it's not snow, then it's ice. Well, water causes a similar type of friction. Submarines and ships are designed with shapes that help them reduce friction and move through water easily. How's a submarine shaped?
It's like a circle.
An oval. Not a circle. That's a ball. That means he got buoyancy. An oval is kind of slender and round and longer. Yeah. So I can see that helping them reduce some friction. Whoever is 122240, could you please let me know in the text box privately who you are? Because I don't know who you are or show your face. It doesn't matter to me. Life move on. My group in here, circle number 2. Circle number 2. None. I'm talking to everything in this room. Do we have to go through that? Okay. Non-contact forces. For friction to work, 2 things need to touch. So for friction to work, 2 things need to be touching. There has to be contact between 2 surfaces or contact with a gas or a liquid. Okay, there has to be contact with 2 surfaces or contact with a gas or a liquid.
My phone with that.
But there are forces that can act on a distance, at a distance. They work even if the object that is pushing or pulling is not touching the object being pushed or pulled. Let me read that again. There are forces that can act at a distance. They work if the object that is pushing or pulling is not touching the object being pushed or pulled. A force that acts at a distance is called a what?
Non-contact force.
Very good. Highlight that. Well, the word non-contact, but not the definition. 3 examples of non-contact forces are, let's highlight 3 examples of non-contact forces: gravity, electric forces, and magnetic forces. We're going to talk about gravity. Gravity. Every object in the universe exerts a pull on every other object. That sounds interesting. Every object in the universe exerts a pull on every other object. This force of attraction between any two objects is called gravity. Only the gravity of a large object such as Earth is strong enough to cause effects that we can notice easily. Without gravity, things would not what? What would they do then? They don't fall.
If they don't stop, they'll float around like
They'll do what?
Like they'll have no gravity, so that means they'll start floating around.
Without gravity, it would not fall.
Well, without gravity, it will not fall. But if there's if they don't have gravity, but what? Wait a minute. If they don't have gravity,
They'll be floating.
they'll be what? Floating around.
Oh, I got a question.
Yes.
So Saturn got those rings, right?
Yes.
Is that a magnetic pull? It's made out.
It could be. It's like, is it like rocks and we're gonna have to Google that. We're gonna have to Google that because I don't want to tell you wrong. But I would think it's like a magnetic pull. What you think? I would think it would be, but I don't know. Because what keeps it going around? What keeps that ring of rocks and ice and everything going around? What keeps it there? So it got to be some kind of pull to it. Some kind of force is behind it. We're gonna Google that.
Space.
Because it's in space. It's cold in space. Well, you gotta look how far the sun is from Saturn. Turn around. Look how far the sun is from Saturn. The farther you are from the sun, the what? The colder it is. The closer you are to the sun, the hotter it is. That's Mars. That's right there at the sun. That's Mars. And then there go Earth right there with third rock from the sun. So that's why we get the warmth in this. Because if we was closer, we'd be burnt up, crispy. Everybody up there, even Pluto. And Pluto's not a planet. It's a ball of gas. Okay, moving back because time is ticking. People over there, I'm gonna give you a quiz. A Quiz. And I want you to PASS it. Can't spell, can you? I want you to pass it. Not well, that's personal. Mm-hmm. Had the magnet broken off the refrigerator?
Like, has it stopped working?
Mm-mm. Do they stop working? They do?
If you put them on, it's
Oh.
some with the magnet.
Oh, I didn't know that. Well, I don't move my magnet. I know you can't put a speaker to a TV screen. You know, a car speaker. You can't put that to the television screen because there's a magnet inside there and it pulls, and then you're gonna have a black spot on your TV. We did it. That's how I know. That's my TV. Well, let's go finish because we almost done. We talking about gravity. Let's finish before we almost done. Gravity pulls objects towards Earth's center without touching them. Okay. So where is the pull going to? The center of the Earth. That's where we get gravity from. The weight of an object is just the force of Earth's pull on that object. As an object moves away from Earth, the object weighs less and less because the pull of Earth's gravity becomes weaker and weaker with distance. So here's a question. First of all, let's highlight that whole sentence because I'm going to give you a scenario. As an object moves away from Earth, the object weighs less and less because the pull of the Earth's gravity becomes weaker and weaker with distance. Look, that's two questions going on right there. Here's a question. Say you weigh 90 pounds. How much you weigh in outer space?
I'll let you 0 prime. Right?
You're
Because
like,
they know because you gonna go straight.
You don't weigh.
yeah.
So that means basically 0 prime. So what if you get?
Okay, here's another one. You going back to 90. So here's another one. What is your mass? If your mass, no, if your mass, you weigh 90 and your mass is 85. What would your mass be in outer space?
You're
It'll be in the
It'll be 85. Remember we talked about this before we got out of
because
school?
your
Mass and weight are two different things. They're not the same.
The mass and weight gonna say, the mass is gonna stay the same.
And your weight would be nothing because there's no weight.
No, your weight on
When you come back to Earth,
Okay, weigh yourself out of
when you
space.
come back to Earth, you gonna still have your same mass.
Plus you can't
Yes.
have, you can't get no scale. How you
It ain't gonna work.
when you get when you get space,
All righty. I know, right? Circle number 5. It's a challenge. And then put a box around, maybe let y'all see what I'm saying. Put a box, oh Lord. Box around at home lab. Baby, you better just do what I told you to do. Cause number one, that side over there really can't talk to me. They don't do nothing. Talk. All right, last one, and we're in good timing so far. Electric and magnetic forces. Hold your questions. Electric forces act between objects that are electrically charged. Just go and highlight it, underline it. That are electrically charged. Oppositely charged objects are attracted to each other and tend to move toward each other. Ooh. Y'all remember? Oh, y'all probably don't. Y'all so young. But in your life, you're going to hear someone say opposites attract and opposites do attract. Because here it is scientifically. Oppositely charged objects are attracted to each other and tend to move toward each other. Objects with the same charge repel each other and tend to move away from each other. Repel means what? Shun you away. Repel you.
And it's like when you all like when you call pest control and they repel people and then they be repelling them the rats and stuff.
Yes. Ward you away. That's repel. That's a good example. Magnets was pulled strongly on objects made of some metals such as iron, cobalt, and nickel. Now, when they say nickel, they're not talking about the 5-cent piece because there's no nickel in the 5-cent piece. None. Sorry. It's just called a nickel.
Which nickel they talking about?
The nickel they're talking about is the element nickel, the element that's found in Earth. That nickel.
And it's like a mine.
Is it a number?
What's the number? Nickel is a number, but I do not know what nickel number is. It's on the periodic table. It is. It's one of those upper numbers, not the big numbers, but the lower numbers, like at the top. Nickel is in it. That's a material. That's a metal. Magnets. Oh, I read it. Every magnet has a north pole and a south pole. North pole and a south pole. Magnetic force is greatest at the magnet's pole. So we got a north pole, we got a south pole. So what about in the middle? Is the force greater in the middle? Or is it greater or weaker?
It's
Weaker based on what this statement said.
Miss Adams, if you put two both to the same side facing each other, the magnets don't push away.
Okay, So you just went back up to the top, what we just talked about. Because if I put the North Pole and the North Pole, I got two magnets, right? And I put North Pole and North Pole together, they're gonna do this. But if I put North Pole and South Pole together, they're gonna do this. So that's why it's called, they are what? They're opposite attract. North is the opposite of South, so it's gonna subtract. Yeah, I can have the same magnet. I just don't have two of these the same thing. This was a quick jump up kind of image. I'm sorry.
What you basically
I don't have two of anything over here.
What you basically saying is if you put two magnets together, they're gonna start trying to push away.
And Thursday, we're going to actually be doing some of that. Mhm. That means you got to log on at 2:00 to see the Zoom. You got to log on to Zoom Thursday to see. Y'all have school at home on Thursday and Friday. But the ones that's at home that come to school gonna come here. They supposed to be logged on Mondays and Tuesdays. Yes, Jacoby. Come on, y'all got 5. I really got 10 minutes, less than 5 minutes too.
Is the Zoom class going to be the same code as the parent meeting?
Yes.
Yes.
What was it? It was my code. Yeah. All right. So we're gonna underline real quick. Magnetic force is greatest at a magnet's pole. The north pole of one magnet will pull on the south pole of another magnet. The north poles of two magnets will push away from each other. The south poles of two magnets will act in the same way by pushing away. Underline circle number 6. And number 8. 6 and 8. Okay. Remember your homework. Your homework is any two vocabulary words of your choice besides force, because we did force last night. Any two of your vocabulary words, and you take them and you make a pyramid tree. I mean a pyramid, word pyramid. A word pyramid. Don't play with me. I'm trying to go real fast because it's time to go. That's math. You did, that was you with that one. When that was awesome. And I didn't even care because hey, you did your work. Everybody ain't no artist.
Miss M, somebody cut the cat fur off.
They didn't cut the cat fur. Look what they did. They got a balloon hanging over that cat. And what's happening?
Oh, the fur came off.
The fur is not coming off, it's just standing up. Electricity. That's an electric force.
I hate that.
This is your word. This is your word pyramid, people. That's your word pyramid. Top tier, you're gonna draw a picture of something or have something related to the word. The next one is you're gonna write and use the word in a sentence. And the definition is on the bottom here where you're gonna write the definition. We just highlighted all the definitions, the ones that, what words we followed today. We got some words today we did. We talked about non-contact, we talked about gravity, we talked about friction, and we talked about contact force. So there go 4 words right there you can choose from today. And tomorrow, your homework is to do 2 more words, understand? And catch up. I pushed out to you some of Stella's math, so I hope you only got 2 steps, a video and an activity, and that's equivalent fractions, introduction of equivalent fractions. That's what you have to do. I don't know. Well, it's like, it depends on how many steps I give you. Like, okay, say for instance, you're on equivalent fractions. You have to watch the video. What I advise children to do is to take notes when watching the video, Because right after the video, it's gonna give you some problems. And then you get there to those problems. If you didn't pay attention to the video, you don't know what to do. So that's why it's gonna keep taking you back over it again until you pass it. You gotta pass with a D. A D. The lowest you can make on it to move on is a D.
So that means every time you get around,
It's gonna keep you back. It's gonna keep it.
and Miss Sarah, every
Yeah.
time you get around, you got 25. You get all 25.
And sometimes it don't even give you that many problems. It might give you 5 problems. And you just didn't make 5, you didn't make a good.
I had an exam and it said who was the first, what was the first one?
You didn't pay attention. Course name, it was an activity he was doing. So are there any question about science? Just know on Thursday, I will be doing an activity under here with magnets. Hopefully I can go downstairs and find my magnets.
We have Zoom tomorrow.
No, I'm not doing, did I say tomorrow? Oh, it's Thursday. We don't Zoom on Wednesday, baby.
Oh,
Babe, guess what? Arvion gonna be taking it over again. Life is hard. It's hot in here, I understand that, but life is hard. Same back channel, same back time next year. There it is. If there's no more questions, we understand. I need your homework though. Now you can give it to me today or you can give it to me tomorrow. Pardon me? Write down what? No, because this was written yesterday. That was yesterday. Video is your friend. All right, Shanice, I'm sorry, Shanice. Shanice, Emma, Isaiah, thank you guys for logging on. Don't log on tomorrow. Be working on Freckle, Savas Realize. That's Pearson Realize, but it's Savas Realize, Freckle, and not Edulastic. Take that out. And Acellus. Because I'm looking and a lot of y'all got some X's. You got to clear it up. Got to clear it up.
yes, ma'am.
All right, baby. And I will see you guys on Thursday morning at 9:15. Have a good
And
evening.
11:30.
No, Thursday at 9:15, at 11:20, and at 2 o'clock.
Oh.
Okay. All right.